Now let us continue creating the this testbench file for this file here. So we can see that we have also all our models, the full adders and the half adders. So now create a new file, Verilog file too, Verilog file. Let us save this as testbench nbit RCA. And then we need to declare the timescale for the simulation unit. So this we did previously with timescale. 1 nanosecond, and then the resolution 100 picosecond, and then the module name, so testbench nbit repository add RCA. Let's end the module. Then we need to declare the parameter. It was 4, n is equal to 4, n is equal to 4, and then declare our input declaration. So we know our input are reg. So in the testbench file, reg n-1. So we have testbench x, testbench y, and testbench s. Output is y, so we have a reg for input, so that is x and y, and we have another reg too. You can just call it here reg. This is another input is carry in, so carry in. And then this is our output. Those are wire, so they are false values, so the testbench is wire. So s is the same as here, a vector of 4 s. So now we need to say ts testbench, and wire for single bit carry out. And then we need to instantiate our design model. So now in this case is n-bit repository adder. So then we give the module name. So you see this is the same as this one here. That file your design, same name. And then our input. So the first input was carry in. and then we have the corresponding test bench carry in. There is our X, and then Y, and then we have sum and carry. So sum, carry out, and then we have this initial begin. So the initial begin is for the time simulation. So we're going to declare the amount of time that we're going to simulate. So the amount of time we're going to simulate is at the moment we go. Let's just leave it blank, and then we're going to explain that time. And then we have this declaration of the initial values. So initial begin, and so we have our carry in. So it's test bench carry in. So when time is equal to 0, we want it to be 0, and the same as x, test bench x is 0, and y. Our time equal to 0, there should be 0. So now we're going to declare our simulation values. Since we have 15 inputs, so we have 15 for x and 15 for y, so we need to declare all of them. Use always. So we're going to create these square waves. So the first one is the x0. So x0, we give it 10 nanoseconds. So we're going to create a square wave with a period of 20 nanoseconds. So we need to invert these signals. So we're going to toggle from each 10 nanoseconds. So this one is x0. So that is the first x input for x. So and then it have a period. So let me say we create create a square wave with 20 nanosecond period. So, and then we're gonna create again for x2. Let's just copy that one. So it needs to be double of the x1 of x0. So here is x1. So now this one is 40. X2. So this one is 80. The last one, x4, which is this 3. So this one is going to be 160. And then we have y. So 160. Each 160 nanosecond. We need to change the signal of y. So now this have a period of 320. 320. This is y. So it will be 640. So we have 640 by 3. Double of that will be 80. 280. This is going to be so now each 10 nanoseconds we create from x, we create all combination of this input, and we create all the combinations of this of y input. So our last simulation time should be when we last create this square wave. And then so after that we need to, what we need to do now is create the initial begin for, to make sure we self-check this our program, and so we're gonna display our values. So let's initial and call this initial begin. So we put the first nanosecond, we just give this an offset, and then we create this like for loop a repeat. We just give this value, how many we got, just begin. Now we need to, so the number that we're going to display, so we're going to display each at 10 nanoseconds. So display, so we're going to display x, so that's the first decimal for x, and then we have, so now we have displayed all the x for x0, 1, 2, and 3 for the 4 bits, and then we want to display our y, and then the answer of the summation. So we can call it um, the sum of the model 1, which is equal to uh, so this is 4 bits, so we'll put that like that, and then we need to give those values. So the first is the x3, which is the fourth bit, and then we have x2, x1, x0, and then we have this y. So just change that one. And the last one is the s. Uh, yeah. uh, and then we need to check this one if it's if it, what we are displaying, what we are testing and what we have created is equal to exactly what we want to sum. So we're expecting the sum if it's not equal to uh, if it's not equal to x plus y, if this is not, so we need to display, for example, failed for RCA. Simple as that. And then we give the expected values, so what it should display, what is the correct answer, because it's just x plus y. And then we need to close this here and merge. So let's analyze and synthesize and see. Now we can see we have some errors here, so let's try to fix these errors. First of all, we need to display the time. So it needs to be 10 here. And then I can do this one. That one. Should be carry in. Try to analyze and synthesize again. Yeah. So everything is run correctly. So let's try and simulate this one now. Let's do this on the next video. We will try to simulate this